Hi everyone, I'm James DeBono. I'm a product designer slash mechanical engineer at Mod Devices. In this video today, I'm going to talk to two guys out of the Netherlands, Jarno Verheesen and Jan Janssen. Both of them have worked with us here at Mod in Berlin. They both now live back in Eindhoven in the Netherlands. Jan continues to work with us as an electrical engineer, while Jarno has another job and he continues to develop plugins. Together, they make VeJa audio plugins. Today, they're going to tell us about what they've done in the past. You might know them for their plugin, the Onyx, which is a tube amplifier simulation, what they're working on, what you can look forward to, and also what it takes to start out as a developer or to get onto the Mod platform. So I hope you enjoy the conversation. Feel free to comment any questions you have. Let us know if you like this kind of content and we can keep doing it. So enjoy. So VeJa is the beginning of your last name and the start of your first name, right?
Yeah, that's correct.
But now instead of Verheesen Jarno, it's Verheesen Jan. Or Verheesen Janssen.
Yeah, works with both my names.
Yeah, it's as if it was meant to be.
Yeah. And you guys have got probably the most Dutch sounding names I've ever heard in my life. So
Thank you. Well, thank my parents.
yeah.
Jan Janssen is pretty spot on for a Dutchman.
Oh, yeah. John Johnson of Holland, right? Okay, so both of you guys are familiar faces around Mod, although myself and Jarno haven't worked together before. We've only spoken briefly, but Jarno was a familiar face at Mod much earlier than I was. But give me an idea of what your background was. Like, I guess you ended up in Mod after studying, was it electrical engineering or something? Were you guys studying together, or how did that come about?
Yeah, I started studying electrical engineering in 2015, and in the second year, I got in the same class as Jan. That's how we met and became pretty close friends. Then Jan got the news of a company called Mod, and it was pretty interesting. And we just started having chats about the internship because it was halfway through our second year, so the period was coming up. We decided to just send an email and see whatever happened. And we got both accepted to intern at Mod in Berlin, which was a tremendous experience for the both of us.
You both interned at the same time.
Yeah.
Yeah.
Jan was actually the one who dragged me into it. I was kind of hesitating, and he was very convincing. I was like, yeah, let's just give it a shot. And I'm very glad I did. I still thank him to this day for that.
You obviously had some interest in, I guess, audio electronics and audio performance. Did you do this kind of thing growing up? Like, were you playing instruments or, making instruments or anything?
That's a funny story, actually. I first got my first guitar when I was 14. My mom gave it to me, and she just asked me, would you like an interest in music? And maybe play the guitar and learn a bit of songs. And I was like, yeah, I'm giving it a try. Played a few songs, haven't touched the instruments for years. And I got into lessons, really started liking it. I had a different career path before. Did commerce management and dropped out of school. Then I started just playing around with electronics because of my love for music and making instruments. And I was just fascinated by amplifiers and guitar effects, the analog pedals, and just started to play with them, tweak them, do some modifications. I started building my own pedals and amplifiers. And that's when I really developed a passion for electronics.
Mm-hmm.
So I decided to take that as a career path and enrolled for electrical engineering. And that brought me to where I am today.
And Jan, I imagine it was a pretty similar experience for you. You were also playing guitar, and how did you get into the electronics side?
I actually started wanting to play out the drums, but my parents were not having any of that.
Of course.
So they bought me a guitar. Yeah, from there, started making some effects pedals, and then actually ended up at the university because they have a electronical engineering / sound engineering there. Enrolled for that, and that's where I met Jarno.
And what sort of got you into the electronic side, and what made you think to combine that with music?
I've always been a bit of a geek, so I was always doing things on the computer and I don't know, taking them apart, switching hard drives and stuff. And I was like, music might not be the most stable career there is, so let me do something that will deliver some money each month, kind of. And that's when because I was actually going to study computer science, but then the electronic aspect of it attended me more. Mm-hmm. Which is quite funny because now what I'm doing mostly day to day is more software than hardware, but still made the journey.
Well, you get the best of both worlds. I always think about the quote from the School of Rock, how he says, "Those who can't do teach, and those who can't teach gym." But in our case, it's more like we want to be musicians, but it's like those who can't make music, we make the instruments instead, or we make the equipment.
It's a nice way of looking at it.
Yeah, but it's I mean, that's a totally different skill set in itself as well. So for me, it was like I have on one side this passion for designing things and the other side passion for music. So yeah, if you can combine them together, it's like the best of both worlds, right? So, I mean, it probably beats designing like LED drivers and stuff, right?
Oh, for sure.
Yeah. Still, those people on LinkedIn that send you a message like, "Hey man, want to design microwaves for me?" I'm like,
I'm gonna pass.
I'm gonna follow my passion a bit more than that.
Yeah. I read somewhere, Jarno, that you actually made a tube amplifier at some point, like an analog tube amp.
Yeah, multiple actually.
Oh, really?
Even before I went into engineering, I was just diving deep into books, literature, searching all the online blogs available just for more information about tube amplifiers and vacuum tubes in general.
Yeah.
So I just started playing around with them, and I warn everyone, it's very tempting, but it's also very dangerous. I learned that in hindsight.
Oh,
I zapped, I think, 2 times, and it's not very pleasant. I can tell you that.
Yeah, I can imagine.
So it was kind of a learning by doing experience, but it was a very fun one.
Yeah. I can also imagine it's a pretty expensive endeavor as well.
At the beginning it is, because you start with nothing, and just putting something together might work, but it might also just fail or blow up in your face or zap you.
Yeah.
So once you dive a bit more into it, you start getting some proper equipment, and that unfortunately cost quite a lot of money.
Yeah.
But it's well worth the investment.
Is that something that sort of tempted you to go more towards digital rather than analog circuitry or analog amplifiers?
Well, that came later. I really started as an analog guy.
Mm-hmm.
Before I hated software. I didn't want to do any digital design. I just wanted to be better at analog.
Yeah.
But that kind of shifted when I was in school. I started doing less and less analog and more software and digital design. And then I just started buying some microcontrollers, started programming them, and the whole world of microcontrollers, computing, software opened up for me.
Yeah.
And then I saw and started seeing what is possible in software. And
for you, Jan, it was probably an earlier start with software, right? You had the passion for software and programming and stuff from the beginning, I guess.
Not when I joined school, because I came more from people I made music with were really into analog gear.
Yeah.
And nothing could beat the 80s Tube Screamer kind of vibe, you know?
Yeah.
And then I was really into that mindset. And then I think in the 3rd year of our studies, we had the most amazing digital signal processing teacher who just opened a whole new world. I took that course with you, actually. Opened a whole new world of actually also calculating the error between something analog and something digital. And then you see those error margins shrinking and shrinking. And then you're like, all right, digital can be really good as well. And that's how I believed in that more and more.
Well, shout out to that teacher. Because
one of the best we had. Yeah. Definitely.
I think I started from an analog kind of background as well, but one way or another you kind of discover the possibilities of digital and the potential for it as well. But it would be nice if more people could have a teacher like that where they can at least see some of the positive sides of digital rather than just seeing it as some black magic that will never beat the authentic original equipment. But not that equipment's not good. We still love analog gear as well. I'm guessing you guys are the same.
Yeah, for sure.
I still have my pedalboard upstairs from years ago.
Yeah.
The actual tube screamer on it.
I mean, with digital, you can get very close to the original sound and feel of an amplifier, but there is nothing that feels the same as having a 100-watt tube amp in the same room, cranked at full volume. Then you can really feel the room tremble and your whole body will shake and really hit the low notes. That's just something you can't do with a plugin and headphones. But that's just a feel thing.
Yeah, I tend to agree. Do you think, though, that perhaps that's something that, not that people are doing wrong, but maybe some people have a approach to plugins and DSP where it's always trying to emulate something that already exists in the analog world? I guess in some cases it's better to look at the opportunities of digital and DSP from just being an open platform, and then to come up with new ideas for, or new sounds for, you know, what's available there, rather than trying to copy something in the analog world. Yeah, I don't know where I'm going with this.
I do really agree. Actually, we made quite a fun plugin that we called the Mutant, and it's called the Mutant because at some point we had, I think, 3, 4, maybe 5 amplifiers. We were like, all right, so we have all these gain stages. Let's just put them all into one amplifier, make it tweakable, make it sound good, and then have a completely new design, which isn't based on anything anymore. It's just all of these different things put into one thing.
Yeah. I suppose that's the beauty of programming, is that once you have a design for one thing, duplicating it is free. So, you know, like you can build a tube amp, but then you don't have the opportunity to just put 3 tube amps in series with each other because you have to build each one. But once you've designed one in software, you can kind of create any number of possibilities using that or other things in different routing scenarios.
Exactly.
Getting a bit off track here. So both of you guys started interning at Mod at the same time. And were you developing for Linux or for LV2 at that stage, or was that something that came from your internship?
At my internship, I made a couple of very simple LV2 plugins. That's how I got introduced in the whole standard.
Mm-hmm.
I also did some generic Linux things, made a small test bench, and I think that was pretty much it. But that did give me a nice introduction into basically a plugin shell. Because before I only knew VSTs existed, because I mainly run Windows, or actually exclusively run Windows before.
Mm-hmm.
And all you ever see in each DAW on Windows is a VST.
Yep.
So when I went to Mod, I got introduced to the world of Linux and also saw the LV2 plugins. And it's a way more accessible format and an easier introduction into making plugins. At least that's what I found, because at the same time I was trying VSTs and it was way more hassle making those properly.
And Jan, were you the same? Like when you started the internship, was that kind of one of your first tasks to start playing around with LV2, or were you also doing some electrical stuff?
Both, actually. What I started working with during my first internship was making fun Arduino projects with the control chain protocol.
Mm-hmm.
So you see a tiny hint of LV2 there in the way the assignments are handled, but that's about it. I was nowhere near the audio plugins at that stage. Right.
So yeah, for you it was more about the electronics, and I guess were you doing some electronics as well, Jarno?
No, not at all, actually.
So you kind of ended up falling into 2 different categories despite coming from the same course.
Yeah, I mean, the industry is very wide. I mean,
yeah.
As an electrical engineer, you get analog courses, but also software. And then you have the software that runs on your computer, or on a platform like the mod, you also have digital design, which dives into FPGAs, which is a whole other beast. So you get a very broad skill set.
Right, and Mod is also a small company too, so having two people starting at the same time, it's valuable to have some different kinds of outputs coming from that, I suppose. And then at what point did the Onyx come about? I should probably introduce what the Onyx is. If you're a Mod user, you've probably seen the Onyx before. It's an amp simulated amp plugin. And it's basically a simulation of a tube amp, but not a clone necessarily of any particular tube amp, right? It's sort of a tube amp of your own design. It is the Onyx. It's its own thing, I guess. And in the mod platform, it's been fairly popular because it's quite a versatile amp. It has a range of different tones, and also it sounds really nice. It's a really convincing tube kind of sound. And props to Andre as well for the GUI design. It looks pretty cool as well. But yeah, so that's the Onyx in case you're wondering. But yeah, tell us, how did that start? Was that during the internship as well, or?
No, it was quite a while after. After I got introduced to the world of LP2, I started making some more plugins for mod. Amongst them are the cabinet simulators, the vintage one and the modern one.
Mm-hmm.
And after that, I started thinking about just amplifiers in general. I made them before analog, and I was thinking, can I also do this digitally? I mean, VSTs were around, and there was already quite some amp simulators, and there are also a few in the mod. And I just challenged myself, and let's see if I can do better and try to make an amplifier that just suits my needs and feels and sounds the way I like it. And I'm kind of a heavy metal guy, so my tone is just a bright, modern sounding amplifier. So that's what I'm aim for. Mm-hmm. I started digging in the amplifiers I made and see how they were built, and took the same blockwise approach I would with software. So I saw every vacuum tube as a gain stage and just looked at what's in front of it, what's behind of it, and what does it do to an audio signal when it passes through. And once you start digging into an analog amplifier, you discover that it's gain stages, which will amplify the signal. They will compress the signal when it's amplifying too much. So it tries to just push down the voltage. That's how you get that sweet saturated overdrive sound. You see what filters are formed in between stages and how they interact with each other. And you try to find a way to mimic that behavior in software. So right. I took that whole breakdown of the analog amplifier, and I started translating that into software blocks. So I started creating the gain stages, I started making the filter blocks, and then added them all together. So I took a listen, didn't quite sound right, because making a one-on-one copy is a very hard thing to do, and at the time I wasn't skilled enough yet. So I manually started tweaking and just playing. So I think maybe an hour or 50 went into actually breaking down the amplifier and translating it into software. And maybe another 50 by just tweaking and playing and tweaking, just going back and forth until I hit the sweet spot. There I had an amplifier that I was really satisfied with. And that's how it seemed to be.
Yeah, it's not just you that's satisfied with it too. It really turned out well. And for a first project, it's really impressive. I guess a lot of people have been doing this for a long time, and I suppose there's no lack of amp simulators available.
No, definitely not.
But it's not super common to find one that sounds really nice and that's convincing. So to do that on the first try, it's pretty impressive.
Thank you.
So Jan, at what stage did you join in with Jarno and working on this stuff? Were you also designing amplifiers at the same time, or was that sort of something that came about after you started to collaborate, or how did that happen?
I guess it started during the first lockdown, actually. Before that, I got pulled into the VOX project, which was, well, a lot of effort to pull off. So during the first lockdown, I got some time available, as everybody, I imagine. And I got back into the DSP and I made this amplifier. And after a while, I was like, all right, what am I going to do with it? Like, it's pretty cool. I did this as a hobby. I don't think Mod wants to release it because what Mod wants to do is not publish plugins and maintain them. It's building the platform. So it's like, can't really put this there. And then I don't know, got in touch with Jarno again. It was like, man, let's do this together. Together we can build more plugins, actually build a brand out of it instead of having these one-offs every now and then. And then we got in touch again and started combining what we did.
So this plugin you were working on at the time, or this amplifier, that I don't know how much you want to go into it, but obviously you and I work together at Mod in the same office, or we were working together. You're now in Eindhoven, obviously. But yeah, I remember you working on this at the time, and you know, coming up with different ways to sort of lay out all of the parameters so that you could test different kinds of gain stages and all these kinds of things, right? So at the same time as building this amplifier, you're also kind of developing your own way of building more amplifiers. Am I right in saying that?
Yeah, what I did at the time is I had all these crazy ideas, the different spot of code, which I thought could work. And I think I built an amplifier with about 120 parameters or something like that. Just, I could switch all the gain stages on and off in between, have different filters, and just kind of tweak out a characteristic of an amplifier like that. And then once I had something I liked, I turned everything down into an amp with one tone stage and one gain control.
Right, so you kind of built an amp builder and then narrowed that down to an amp.
Yeah, and actually by the time I came in touch with Jarno for the amplifier, I was like, man, can you just pass me the gain stage of the Onyx and I can put it in here and maybe it will work out with something else. And I think also that's the beauty of our co-workship on this.
Yeah, exactly. We make small modules and you can see them as a small filter or a new gain stage or some other crazy feature that will sound really cool. And we just have a big Git repository shared amongst us and we just post everything there. And we can just grab each other's work and inject it in our code, see what it does. And when we find something cool, we just rush to each other and say like, yo man, I just took your code, I put it in mine and it sounds freaking amazing. You should come check this out. It's real fun.
That's awesome. And it's great that you guys like, you know, found that collaboration together too. That's really cool. And it sounds like you're being pretty productive with it. Jan, do you want to talk about the amp or?
Yeah, for sure.
So it has maybe a placeholder name, maybe a final name. It's not yet been released in the Mod platform, but the intention is to get it in there somewhere or another, right?
Yeah, the Rambler, as it is called now, you're talking about, right?
Yeah.
Yeah.
The Rambler is the result of this amp builder sort of funneled into an amp, right?
Yeah, exactly. And a lot of tweaking, a lot of back and forth between me and Jarno at the time. At the time, I was still living in Berlin, so we were doing this back and forth thing on GitHub until we got something we both liked. It's a bit more of my taste. It's a bit deeper than how I would say you tweak your guitar, but
yeah,
I like it a lot.
Yeah. So what would you say it sounds similar to, or what kind of tone would people expect from the Rambler?
I actually took some parts of I actually took some inspiration of an old amplifier I have laying upstairs here, which is an old London City, I think from the 60s.
Right.
Which in its turn is based on the older Marshall designs.
Okay.
So I kind of took that tonal characteristic and then just added a lot more gain. because I love the gain that an amplifier creates in most cases more than putting a drive before the amplifier.
Yeah.
And that's the beauty about software as well, is that you can just crank that variable and see what happens. There's no limit.
There's no prototyping or soldering or ordering germanium diodes from Eastern Europe or something.
Yeah, exactly. If it goes to 10, it can go to 100, and it might crash. It might sound really nice.
Awesome. So that's something to look out for, and it's more of a heavy kind of tone, right?
Yeah, a bit more dirty, I would say, especially if you crank it. But it can be quite smooth and full as well.
Cool. So if you're a mod user or if you're on the platform, then that's something you should keep your eyes open for. And something else that you could keep your eyes open for is you're preparing to release a new amp, right?
That's correct.
Yes. And it's in the process of being, well, it's in kind of its last stages right now, right?
Yeah, there are just 2 minor tweaks that still need to take place, and then it's all good to go.
So tell us about this amp. What kind of amp is it? What should people expect? What's it called?
Well, let's start with the name. The amplifier is called the Titan, and it's basically the big brother of the Onyx. I started from scratch with the amplifier and thought to myself, what can I improve in my last design? And the first place where I started looking was the gain stages. And I took a way more mathematical approach. I dove into the best mathematical tools that are available and started recreating the behavior of vacuum tubes in mathematical models. And it sounds pretty complex, and I promise I won't go more in depth than that. But I was able to recreate the behavior of a vacuum tube and transform that into very efficient pieces of code. Once those gain stages were made, I took a similar approach I did to the Onyx by making the whole filter stages in front and after each tube stage. But at the time, I gained a little bit more knowledge. I know where to look for. I know what to change in the digital realm instead of the analog realm, and that's how the Titan, well, basically came together. I added another channel, so it's a 2-channel amplifier. It has a very straightforward clean channel, which will just be very bright and nice and clean. And of course, the lead channel is pretty modern and pretty dirty.
Cool.
It's a very high gain amplifier when you crank all the buttons or crank all the knobs.
So what sort of tone or what kind of genres were the inspiration for the tone, I suppose?
Well, for the lead channel, it was mostly metal because I'm a modern metal player. It's based on a 5-channel super lead overdrive preamp from Soldano. I once made a clone from that, and I absolutely love the sound. So that became my my base inspiration for this amplifier. And for the clean channel, it's not really based on any amplifier. I just went with my gut feeling, placed I think 2 gain stages after each other, added some filters, and just started playing around what sounded nice to me. And to me, a clean sound is just nice, articulate. It's not too gritty, not too gainy, just very well balanced and chimey. That's how I like my clean channels.
Yeah.
And then for the lead channel, I wanted it to be pretty bright because that's the kind of sound I prefer. From my experience, it pairs just really well with a more bassy sounding cabinet. That's usually what I do. I mean, if the amplifier is a bit too bright, you just pair it with a bit more mellow cabinet and vice versa. But when I really go for a low-tuned instrument like a 7-string or even an 8-string guitar, which I sometimes also play, I want as little bass as possible to really get a very nice, genty sound, which I also really dig.
Yeah.
So for me, that feature just had to be in there. So that kind of like became my inspiration.
Awesome. I'm looking forward to playing it actually, because I'm actually excited about the clean channel. Although I like heavy music as well, maybe not so much metal. Well, some metal. I'm more into maybe some progressive and stuff, but I like playing clean stuff as well. And I really like that chimey kind of tone. So I'm excited to play it. But that's awesome. So if you're once again, if you're a mod user, you can expect to be playing that probably early 2021, maybe?
Yeah,
Perhaps earlier?
maybe even earlier.
Yeah.
The
Awesome.
final changes will be made this weekend, and then it basically gets a green light.
Cool. Well, there's something to look forward to. So you said this time you went with more of a mathematical approach, as opposed to an electronic approach that you sort of went into it last time. What sort of is your process of coming up with an idea of how, did you decide you wanted to make an amplifier first, or was it something that you learned about the mathematics of it that you thought maybe I can apply this? Like, what was the process of coming up with the idea for that?
Well, it obviously started with wanting a new amplifier, and doing the same thing you already did becomes pretty boring pretty fast. So you try to improve yourself. And during my college, I gained a new skill set, and I decided to apply it. And that was, as Jan mentioned before, the advanced DSP course. So I started analyzing the behavior of a vacuum tube, see what happened when an input signal on its grid would rise, what it would do to the output signal. You can transform that formula into a waveform. And once you have a waveform, you can extract data points from that. And then from there, I went just deep into the algorithm. I broke the behavior of the signal down into components and found a way to translate that into basically an algorithm I could run within a plugin.
Mm-hmm. And what was, once you sort of had a prototype of that working, then what was your process of kind of evaluating like whether this method that you were using is going to be the right way to approach it? Or did you come up with a lot of different iterations, or how did you sort of end at where it is now?
Yeah, it's definitely an iterative approach. I mean, the mathematical tools I use get you pretty far, because once you have the model, you can also apply it. So you get a visual representation of how your signal will look. And you can view that in a similar way as where you would play an open string on your guitar. You would actually see the waveform being played and put that waveform through your effect. And then you can see what your effect does to that waveform. And that way you can see like, hey, the thing I made creates the exact same output as my analog amplifier made. So the algorithm I wrote must be correct.
Right.
So you will sit at some different frequencies. You will start playing some different instrument, playing through a different cabinet, and see like, hey, it plays and feels really close to your original thing.
Cool. I mean, it makes total sense to make the direct comparisons, because then, yeah, you don't just want to try to emulate the design, I suppose. You want to emulate the result. So
exactly.
Yeah. Awesome. So coming from having the experience of designing a tube amp in the past and now designing software amps, how does it differ? Or is it purely just the practicality of it, the technical implementation of coding rather than soldering? How does it compare? Are there any other differences? Are there some advantages or disadvantages for either, or any surprises that came out of working with software?
I think both have their charms. There is nothing that beats making an actual tube amplifier. You solder all the components together. You make late hours with your hot soldering iron, attaching everything to each other. Then you finally insert the tubes when it's ready. You flick the switch. You slowly see them heating up and lighting up. You see the beautiful orange glow. then you hear the sound slowly fading in, and your beast or your beauty coming to life. It's a different feeling. So that's definitely.
And then you feel the sharp burning sensation in your fingertips.
Yeah, you shouldn't hold them too long. And I mean, with software, it's the ease of you can just make it wherever you want, wherever you have a computer. You can work on it. You can work on it when you're in train or just doing nothing. And it's pretty much free. Once you have a computer, you can install Linux. You just download all the headers you need to make LV2 plugins. You download the host, and you're good to go. So it's basically no entry at all. As long as you have a computer that can compile a plugin, you're good to go.
Yep. Right. So you sort of have.
There is the coding background that comes into play, but the same goes for analog when you want to make an amplifier. You also need to invest quite a lot of time and effort and money into acquiring the skill that it takes to make one.
Right. Yeah, I suppose you have the freedom on one hand with software, but then you have this different kind of intrinsic value of like having a solid thing in front of you with analog gear, but they both have their advantages, I suppose. So, like I said, working with Jan, I occasionally hear a few things that are going on with you guys, but not being an electrical engineer myself or having any idea about coding or programming, a lot of it bounces straight over my head. But I've heard Jan mention some things about modeling amplifiers from electrical circuits or from schematics. Is that something you've been working on as well? Like actually trying to convert schematics to DSP, I suppose?
We have two projects going on kind of simultaneously. So what we're trying to do with that is we're trying to model schematics up until their non-linearity. So mostly for filters or tone stacks, the behavior is relatively easy to predict, but then you get to the gain stage and things become non-linear, and that's where things get messy in the math. And for that, the approach we're trying to take right now, actually Jarno's been working a lot on that, is to take AI approach on that. So to use artificial intelligence to predict the non-linear parts while keeping the linear parts directly from the schematic.
Right. So this is kind of the difficulty of something like an impulse response. You can't really use an impulse response or you can't use an impulse response for an amp because you have these it's a dynamic response, right? So that's where it gets complicated. Right. So how are you able to implement AI to solve that?
Well, it starts with, or it basically comprises of two things. You have the actual AI model itself, which mostly is just a file with a lot of parameters for your model to play. And then you have a piece of code that can actually play your model, which will implement your AI. I'm not sure how in depth we can go on this because it's pretty vague in terms of what's inside. Mm-hmm. But what we're trying to do is basically make a small machine that will learn how to play or how to mimic an amplifier. So what we do is we first take some playing of a guitar of like 5, 6, 7 minutes, and we play that through an amplifier we want to mimic or we want to clone, so to say. Once we have the output signal, we feed it into our machine, and our machine is very dumb. The only thing we do is set a few knobs. We say like we want these settings, and we just see how well this machine will train itself. So once we give it the parameters, let's say we want a model that is this high, maybe 20 layers high and 5 layers wide, and it will just start going training. It will take the input and the output and will just see what it will make with some random values on each knob. Then our training program will say you did a very bad job to the machine. And you say you have to do better. So the machine will adjust its own knobs, and then it will run the same training routine. It will get another result, and it will give it to the one that's teaching it. And it might have done slightly better, it might have done slightly worse. If it's done worse, it gets whipped, and it will train to do better. And then once it starts doing better, you keep training it until it does better and better and better. And at some point, it becomes very good at creating the same output than your reference. And then at that stage, you stop the training and you give it some new data. And then you see how well it will create an actual output signal compared to the amplifier you're trying to clone. Very rough explanation of what we're trying to do.
And at what stage of whipping will the artificial intelligence turn against you?
Fortunately, we're not at that point yet. And all it will ever do is predict what the correct output will be. It will do nothing else. So it will cause no harm to us or humanity whatsoever.
Yeah. It'll just cause harm to your guitar tone, I suppose.
Well, hopefully it will make it sound beautiful. If it's trained badly, it will make it sound worse.
So I'm curious, just from a technical aspect, I'm still trying to wrap my brain around it, but would it then be able to translate that information into something where you will actually be able to change, dials for gain and that sort of thing, and it would be able to smoothly, adjust your gain or your brightness and those kinds of things? Or is it sort of breaking it into images, like steps of, this is how it sounds at this setting and this is how it sounds at this setting? Or can it interpolate that into a scale of, low gain to high gain?
The algorithm we use is pretty widely used in the stock market for branch prediction. So what it will do is use whatever it's already seen and will predict what will come next. So if you play a guitar, you also have the change in volume. When you hit a string, you will get the envelope where when you just hit your pick, you will get a peak in amplitude, and then it will gradually decay. That decay will also be translated into the output of whatever your AI is doing. So it's trained to also respond to behavior of a signal over time.
Okay.
So just as well as a stock market can be stable and then suddenly peak, your AI will know this is probably some random event because this generally doesn't happen. And the same goes for applying it to a guitar.
So it dynamically adapts to the sound over time.
Yeah, exactly. It will use whatever it's already heard to predict whatever is coming.
Will you be able to have control over parameters, like amp parameters as well? Like all your EQs and stuff, or is that before the?
Yeah, well, the AI is split up into multiple parts, as Jan was hinting at.
Yep.
So we will not just make one big clone of an amplifier, because that would just capture it in one setting. So then you would have your gain, your bass, your mid, your treble. It would all be set at one position.
Yep.
So what we're trying to do is capture each individual stage. So before your gain knob, and then after your gain knob until your tone stack, because in all amplifiers, that's where a user doesn't have control over whatever happens to the signal. So that's the part that we're cloning.
Right.
And then once we get to the tone stack, which is all linear, we will go to the algorithms that Jan was talking about.
Yep. Okay, gotcha.
And then afterwards to the output stage and the transformer, that's being captured by the AI again.
So the end result, it won't just be like one captured state of an amplifier, but it'll be a completely dynamic amplifier which has sort of captured states of each stage.
Yeah, and there's another benefit to it, and that's efficiency. Mm-hmm. Because making a model of an entire amplifier takes way much more processing and resources than breaking the change the amplifier into smaller stages.
Yep. Gotcha.
because it will be simpler to model it.
Okay, it sounds pretty cool. I mean, AI seems to be a buzzword, in recent years, but it's awesome that we can, or that you guys can, find ways to adapt it into our industry as well, because it's going to allow us to do something that we weren't able to do before, I suppose. That's really cool. And we're talking about amplifiers now, but could it also be applied to other kinds of effects?
The whole neural networks generally work best for nonlinear systems, because if you make a time-based effect like a reverb or a delay, you're way better off using other algorithms because they're just inherently more efficient.
What about if you wanted to just use AI to directly clone a pedal or something?
You would. If you just take any overdrive pedal like a DS1, you would be able to just apply an input signal, capture the output signal, and then feed it to the trainer we're using. And then you can capture the pedal. I mean, you lose controls because the tone would be fixed in one position.
Right.
But that's a sacrifice that, well, you have to take them.
So you're looking at either having a quick way to clone a sound without control over parameters, or you can go the longer route and do it algorithmically, and then you get the control over parameters.
Well, there's no real quick way of cloning a pedal. The training takes quite a lot of time. It takes my very powerful NVIDIA GPU and a quite powerful CPU. And to train a simple amplifier can easily take me up to 2 hours before it's a model that's acceptable.
I ask this because Jan tried to explain this to me at some point, and we were contemplating the idea of, like, could this be a plugin on a mod device like a Duo X or a Dwarf, where you could plug your inputs and outputs directly into another pedal, press a button on the mod device and hit clone, and then just wait for it, and borrow one of your friend's pedals, plug it in, hit clone, and go, okay, I don't need this anymore. It's saved.
Yeah, technically it's possible, but you're gonna spend hours cloning. Yeah. And with hours, I mean hours.
Yeah,
that's the downfall.
We set the threshold on 15 minutes, and we said to ourselves, if it cannot be done within 15 minutes, it's probably better to turn it into some desktop application if we ever do this at some point. Because that spending 4 hours in a rehearsal room just to clone a pedal doesn't make a lot of sense.
Yeah, I mean, it might be possible. I'm not gonna lie. I can pretty much tell it is possible because you see other companies doing it in the market, even in other industries. But those are very big companies throwing millions at AI development and making very good training programs.
Yeah.
So that's
and
it's a huge investment, and it's not easy.
And I guess we have limited processing power in a portable music device as well. I mean, you're stepping down from a NVIDIA graphics card down to sort of inbuilt graphics on an SoC. So, but it's cool that the potential is there. But maybe we can put it to better use in other places.
Yeah.
I wanted to ask about your workflow, but we've kind of gone over the workflow a fair bit. But something I left out is, what happens when you come to a point where something isn't working and you don't know what to do? You find these roadblocks, or like, how do you overcome these blockers? Like, do you spend a lot of time stuck on things, or?
Well, it's pretty hard because I'm an electrical engineer as a full-time job as well. Can be pretty hectic, and currently we're having quite a lot of deadlines. And when you hit a roadblock with plugin development, you just think, no, I'm not going to do this today because I already had a rough day. So they got to get bulldozered to the future, I must admit.
Yeah.
But whenever I really want to tackle them, I usually just go over it again. If I'm stuck, I just come to Jan and say like, yo, just help me with this code, look it through, see what I'm doing wrong, and just brainstorm about what it can be and what we can do to fix it. And sometimes it requires the deletion of a piece and rewrite it from scratch. That happens sometimes, and other times you work it out.
Right. Do you find it painful to have to go back to square one, or is that something you're okay with?
No, not at all. I mean, you try to develop something, and if you try something that you have in mind and it doesn't work out, at some point you have to realize this is not working. I have to start over or do something differently.
Yeah.
And if you spend an hour or 5 of your life into a mistake, you better know not to make that mistake again.
Yeah.
It's like spend 5 hours looking at these 20 lines of an algorithm and this isn't working, and I finally figured out why. I'm the biggest idiot there is. You always learn something along the way.
Yeah. Yeah, and sometimes you have to eat your losses, I guess, and start again, but you never lose the lesson that you learned, I suppose.
No, exactly.
So what is, I didn't ask this earlier, but what is the vision now for VeJa? Do you have plans for new devices, new plugins? Do you want to stay with plugins, or what's the vision? What's the goal here?
Well, for now, it's just getting the Titan released. We have quite a few other plugins still floating around, and whenever the mod labs comes live, we have a new stream of plugins that will flow on there. There is a noise gate coming still. Working on some other projects, and the two biggest ones are the WD app that Jan is working on, and the neural networking stuff that I'm mostly working on.
So, sorry, what was it? WDF?
Yeah, it's wave digital filtering.
Right.
It's a way to turn schematics into code, kind of, with a lot of steps in between to briefly go over it. And it's been used quite a lot, and it's has a super low error margin as opposed to using Kirchhoff's law, like actually calculating currents and voltages. This approach is a lot more accurate. So we're hoping to combine this with the neural network stuff to have this handle linear parts and the neural network handle non-linear parts to hopefully get to a next level of plugins.
Awesome. All your powers combined.
Yeah, exactly.
That's awesome. So
those are the two biggest things that are being worked on at the moment.
Cool. We're all looking forward to what comes out of that. What about beyond plugins, or is plugins mostly the scope for now, or do you have any other ideas outside of digital or anything? Maybe that's looking too far forward.
No, for me, it's now mainly just plugins and staying in the digital realm.
Yeah.
I mean, I know what it takes to make an actual hardware device where I can run my own software, or making a cloning device that will just be an amplifier you clone, similar to what is it Camper is doing, just to point it out blankly. That's not really one of my ambitions.
Okay, hopefully Kemper don't hate on us for that.
No, it's definitely not hate, but I love what they're doing, but it's none of my ambition to go that route.
I mean, a lot of people love what they're doing and they do great stuff, but we're kind of coming at it from a different angle, right?
Yeah, exactly.
Yep. I was going to say, we're all busy with other things as well. You have another job that you're working, and Jan and I are both working on stuff with mod, like the Duo X and the Dwarf and stuff, which just takes a lot of time as well. So, but it's awesome that we get to do these other projects in our spare time. Why do you think it's good for developers to work with LV2? What attracts you to LV2, and why do you think that it could be attractive for other developers?
For me, it's accessibility and ease.
Mm-hmm.
I mean, the first plugins I developed were LV2 plugins, so I might be a bit biased. But if I compare it with compiling a plugin in VST with the Steinberg libraries and Visual Studio, I was having a way worse time than I was on Linux, where I just had my command line. I had a mod. I had instruction pages on how to build for a mod. I just typed in 4 commands, and there I had it. I could build my plugin. So I basically went from having nothing to having a plugin in like half an hour by just following some clear instructions.
Right.
So the entry level was just so low, and it was a very simple plugin that would just pass through audio. And then you discover the main loop, and it's like, oh, this is where I can alter my sound, and you just started playing around with it, adding a small gain block, and now I can amplify my sound. And you start making effects and trying to do weird things with the sound. It's very accessible.
Yeah.
If you have limited coding knowledge and just know some basic C or C++, you can make your first plugin within hours.
Yeah, I think that's the key word there, is accessible.
Yeah, it doesn't take a complex IDE or anything fancy.
Yeah.
Just follow a few very simple instructions, and then you can get off to a good start. At least that was my experience with it.
Notepad and terminal. It's all you need.
Yeah, that's all you need. That's really true.
Well, I mean, going from starting to develop into LV2, and then your first plugin being the Onyx, is, I think it's pretty good. It's good evidence that you can do good things pretty quickly with LV2. What other advice would you have for people who might be starting out? Like, there's probably a lot of guys out there who think it would be really nice to have, my own. I want to have a specific amp sound, or I want to have a specific effect or something, and coding seems too difficult for me, or something like that. What would you suggest to those people if they want to start out with this kind of stuff?
Well, if you want to write plugins in code, then you do have to learn some coding. I have to be very honest in that. I mean, it doesn't have to be very fancy coding. I can write some pretty crazy lines of code in C++, and Jan will almost throw his shoe at me for writing such complex thing that he can barely read. While he writes a very scriptic C thing that does the exact same thing, but I'm like, no, that's all wrong in our code style. It does the same thing, it's just written in a very complex way or a simple way.
Yeah.
So it doesn't really matter which route you take, if it's a very difficult piece of code or a simple piece of code. As long as it gives you the result you want and you understand what it's doing, you can basically do whatever you want. And I think the second one is taking a good approach. See what the effect is you want to make, and do some research. If you want to make an amplifier, see how they're built, see what's inside, see what happens to the sound. Same goes for a reverb or a delay effect. See what goes into it. If you take a delay, you have to remember what the input signal was and play it back at a later time, but at a different volume. And if you start thinking like that and deconstructing what your effect is doing and how it affects your signal, you can translate that into small chunks of code, which you can understand, because no one's going to write a plugin from scratch, from start to finish in one go. You're going to divide it up, and you need an understanding of what you're making before you even write a single line of code. I think that's the most important thing. Get a clear picture of what it is you're making and translate that to something you can understand, something you can easily test, and you can verify that it does exactly what it's supposed to do. And you can,
I guess there's some other tools too which people could use to kind of get a better understanding, like you're saying, before they touch the code. Like, you could try things in Max or some other builders like that, and then that's probably a really good tool to get your head around, like, how will these different elements affect the audio, and then you can kind of take that from an interactive builder like Max and turn that into a code thing where you might have a bit more control over exactly how you want to treat everything. Cool.
For sure. Yeah, especially on the DSP side, there's so much out there to read on the internet. Like, Side One source in particular, I see myself browsing ear-level engineering a lot. And that blog is just amazing in explaining
What was
everything you need
the
to know to
blog
get
called?
started in all kinds of plugins, from synths
Ear
to
level.
guitar amps.
Oh, okay.
Ear-level engineering. Yeah.
Awesome.
Yeah, they have a blog
Awesome.
hosted, and I scroll it regularly.
Well,
The
yeah,
guys
if you
really-
are a beginning developer and you want to try some things like this out, or if you have a Duo or a Duo X or a Dwarf or something, you want to try something, you could start with Max, and then you can compile, you can put your Max patch onto the mod device, and then you can start developing an LV2, and then that's, you know, that's kind of I mean, once you're an LV2, then that's it, right, for our platform. And then, yeah, eventually you could get to, well, soon we won't have the beta plugin. Soon we'll have the lab store, and you'll be able to publish plugins to the lab store. And then, yeah, then it gives you an opportunity to not only just test out your own plugin, but you can share it with other people, or yeah, just make it available for everybody else, and you might even find somebody to collaborate with, and then you could start something like your own VeJa.
Exactly.
Awesome. All right, well, I'm starting to lose my mind now with these questions, so maybe we can we can wrap it up. But I want to thank you guys for taking the time. It has been just over an hour now, so but yeah, it was awesome talking with you guys. And if you're going to follow along with these videos, I'm sure you'll hear more stuff from both of these guys, and you'll see the plugins coming up very soon. So yeah, thanks again, guys. And is there anything you want to plug? Do you have anything VeJa related that you want to, any websites or anything? I don't know.
No, there's no website yet.
Okay.
Just outside on the mod website, they will pretty sure announce when the Titan is released.
Yeah.
You should all check it out. It's a very cool amplifier, and we got guys posted for any new updates or cool features.
Awesome. If you do like this kind of content, let us know. We can do some more interviews with other developers or some musicians or other collaborators.